Hi, this is Dan Malloy from NYC Math Tutoring and Test Prep. I've been getting a number of requests for GMAT videos, so if you're interested in that, then comment or like this video, let me know, and we'll do more. So I'm going to do a series here starting with a few challenging GMAT problems. There'll be varying levels of difficulty and a wide range of topics, so if you're preparing for the GMAT, then this will definitely give you a broad spectrum and a good challenge. The best way to use these is to pause the video at the beginning, take a look at the problem, try it on your own on a whiteboard or a blank sheet of paper, and only watch my explanation after you've completed it to A, see if it's correct, and B, see alternate ways of looking at the same problem, maybe recover some of the fundamentals if you were struggling through it. And if you get it 100%, then obviously there's no need there to watch the videos. Okay, a circle with center O has a circumference 6 pi root 3. If AC is the diameter of the circle and angle ACB is 30 degrees, what is the length of segment BC? Okay, so let's start with a picture. Almost impossible to do this without drawing something. So we have a circle, and we have a diameter AC, and I don't really know where A and C should be, but I'll just guess. And there's an angle ACB, so ACB. I'll just pick a random point B. I don't know where it should be, so I'm guessing. And we know that angle is 30 degrees. And they want to know the length of line segment BC. So that's this guy here. So what do we know here? We know that the circumference is 6 pi root 3. So let's recall a fundamental definition of a circumference. Circumference is 2 pi r, which is the same as pi d. So if we know the circumference is 6 pi root 3, then we can find the radius or the diameter. So let's do that. Let's find the diameter AC, because that might be useful to us. So we have circumference equals 6 pi root 3, and since we're after the diameter, I'll use this equation. That equals pi d. So pi's cancel on both sides, and the diameter now equals 6 root 3. Okay, but we want to know the length of BC. So we need a little more information here, and it has to do with the angles. So we have a known diameter now, and then we have this leg that comes off at an angle. And now if we draw a triangle, this is a pretty big insight here. You may recall from geometry that a triangle inscribed in a circle, where one of the legs is the diameter, always meets at a 90-degree angle. So that's pretty helpful, right? Because imagine that B hadn't been drawn there. If I could have put B here, and you prove this to yourself by drawing multiple circles and picking different locations for point B, and draw AB and CB. And what you'll notice, let me just do another one below so you can kind of see this, kind of get a feel. So you have some diameter, and now you can draw point B anywhere. And this probably isn't to scale, but if you take my word for it, that's always going to be at a 90-degree angle, which means that the other two angles, since the sum of the internal angles of any triangle have to add up to 180, the other two angles will add up to 90, because 90 is there. So if ACB is 30, then this angle, angle A, must be 60. And now you might also recall, for a 30, 60, 90 right triangle, that the lengths of the sides of that triangle are always in a certain ratio. And I'll write it here. We have the shorter leg is to the longer leg is to the hypotenuse, and I'll put what they actually are below. So if the shorter leg is 1, then the longer leg is root 3, and the hypotenuse is 2. That is to say that the hypotenuse is always twice as long as the shorter leg, or the shorter leg is half as long as the hypotenuse. The longer leg is always the shorter leg times root 3. Or if you have to go from the hypotenuse to the longer leg, you divide it by 2 and then multiply it by root 3. So they always occur in this ratio. In our case, we have the hypotenuse, which is the diameter of the circle. That we know. We have that already. And then we have the shorter leg, which is across from the smaller angle, the 30. And then we have this longer leg, which is across from the larger of the two non-right angles. Notice I said longer, not longest, because the hypotenuse is actually the longest. So we're actually ready to go. We have the hypotenuse, and we want to know BC, which is the longer leg. So how do we get there? We divide by 2 and then multiply by root 3. Or you can think of that as multiplying by root 3 over 2, however you prefer to think about it. So we have 6 root 3. We're going to divide that by 2. That gives us the shorter leg. That would be 3 root 3. And now we're going to multiply that by root 3. So what is 3 root 3 times root 3? Well, root 3 times root 3 is 3. So this thing is just 3 times 3, which is 9. And that's the answer.